So our next talk is by Joshua Latt from Leo Grocer, Securing Your Production Ruby Applications.
Thank you. Alright, so good afternoon everyone. I'm Joshua Arvin Latt and I'm the Scrum Master of Leo Grocer. So today, I'll be talking about security. So earlier this morning, I actually woke up a bit late and I was looking for my clicker. Then I realized that my clicker was missing. So actually, I was looking for it for about 30 minutes. Then I realized, hey, I'll just use my remote control of my TV. Then because I think last year, I was playing PS4. And then when I had a PowerPoint presentation here, then when I used the remote control, suddenly my computer responded. Then it went to the next slide. I was surprised because I didn't know that it was possible to control the computer with a remote control without any configuration. So this is actually related to my talk because the hackers actually think differently. The attackers, well, crackers, the attackers think differently, and they, even without tools, they can actually compromise your site. So today, I'll be talking more on that, and these are the 5 main parts of my talk. So the first one is about awareness. And then second part would be that in order for you to defend your sites, you have to know how to attack, or at least understand the process that the attackers follow. And then you have to know what to protect also. You cannot just start protecting your site without even knowing what to protect. And then the fourth one would be knowing how to recover. It's critical because sometimes you have to actually stop the attackers from attacking your site in real time. And then finally, automation. Alright, so let's start with awareness. So 4 years ago, my thesis mates and I actually joined a competition. So it's called IT Security for the Next Generation. So that was the time when I became more aware of what's really happening in the world. I actually realized that security is a big field, and I got to talk to a lot of people from other countries, and I got to see their research projects. And we actually won the competition, and luckily we had a few marketing stuff for free. So for example, we had a billboard, we were published in the newspapers, etc. So actually there were companies who were actually told us, hey, you should start your own company. You should sell your product, so on and so forth. What I realized after winning that competition is that security is a big field. It's complicated. We realized that we weren't ready for these things because at the end of the day, the attackers probably know more than us. Probably there are zero-day attacks that aren't even in the internet, which you cannot even see in the internet. And I realized at that time that security is like love. Love is complicated. And it's a big field. And I realized that there are a lot of things that you think are right, and then you realize that you're wrong. So the theme of this talk is about love and that it's complicated. But I'll try to make it simple for you. And I'll try to explain how the entire process works. So after winning the competition, what I did was that I wanted to learn how the attackers actually do it. I wanted to try to reverse the process that instead of trying to defend the site, I would like to learn more on how the attackers really do it. So actually I got these things before, and I realized that there are so many ways that the attackers can actually try to change the way your tools actually work. So it's not just about getting access, it's about making your tools work in ways that it's not supposed to do. So that's what a hacker does, so on and so forth. There are different definitions actually. So for this talk, I'll be using the word attacker to describe people who are attacking your site. And then I joined Leo Grocer, and then for about 3 to 4 years now, we've been building e-commerce sites. So security is a big module when it comes to the features that we're trying to build. And we realize over time that if we forget to, for example, have CSRF protection, attackers will actually try to attack your site with those types of attacks. And there are also brute force attacks, there are denial of service attacks. And sometimes it's important for you to know that there should be some way for you to know which behavior are normal and which ones are abnormal. Because sometimes you'll realize that the ones attacking your site are actually your devs, and they have accidentally took down your site. So this happens almost every month. So there are always problems, and then we realize over time that hey, we should make the site self-healing, and so on and so forth. All right. The second part is about knowing how to attack. Pretty dark, but then if you have to defend your site, do you have any idea on how to prove the security of your site? The only way to prove the security of your site is to test it yourself. If you have no idea how the attackers do it, and you, for example, install a firewall, how do you prove that, or how do you make sure that the attackers will be able to get past that firewall? Or maybe the attacker probably has some other way to get into your site. The only way to know how to defend is actually to know how to attack. Alright, so let me share a quick story. Last year, we had a test server, so the orange one over there, and then AWS actually emailed us that one of our servers was actually attacking other servers. So the orange one was our server, so luckily it was a test server, so no data was taken. But then these three or four other target machines were actually affected. So luckily the test server wasn't, I think it was correct that the database was empty. So the things which could have probably been taken away was the source code of the code. So luckily, no credentials were actually taken there. But then, what was weird about the attack is, one, how was the attacker able to get access to the site? And even before the site could actually do denial of service attacks to other machines, the attacker should have, for example, access to your server. Actually, the solution there is simple, just turn off the server. But if you think like that, you'll realize that the other servers you have configured are actually configured the same way as this test server. Probably all your test servers have been configured the same way. So what if the attacker, for example, no longer had access to that server and you take that down? What happens to your other servers? Your other servers probably have the same weaknesses. And before you take down that server, which the hacker attacked, you have to analyze what happened. You have to tell everyone that, hey, don't do this again. Let's close the ports, so on and so forth. So I'll share what happened last year. Alright. So the first thing which happened last year was that the staging server attacked the other servers. So after the attack has been stopped, I had to check different places on where the attacker actually lived, probably backdoors or probably a way to access the server remotely. So I saw the authorized keys. So weird enough, I found something like this. And I realized that, hey, I should check the other places because the things which the attacker can actually do is one, upload files to your computer. There are already automated tools which allow the attacker to do a lot of things inside your server. And for example, in Metasploit, there's Meterpreter and so on and so forth. There are already operating systems like before it was called Backtrack and now it's called Kali. All the tools that attackers and penetration testers actually use are inside that already. So a lot of things have already been automated, and even though the attacker doesn't have any knowledge on the tools that they're using, if the attacker knows how to use these tools, even the basic ones, they can actually exploit a lot of servers already, because sometimes servers get attacked because it has been configured incorrectly. And configuring your servers properly and having enough security protections would already stop most of these attacks. So, So what helped me before, it took me actually 1 to 2 hours to remove the backdoor and analyze what happened. It made me realize that, hey, my familiarity with some of these tools made me know what was possible. And it helped me know where to look for, which the attackers probably have used or probably put some additional files inside the server. So now, for example, Nmap, so you have something which can be used for port scanning. Actually, it's not just port scanning, you can do a lot of things with Nmap. And then there's Metasploit. Some hackers don't even use Metasploit. It allows people to understand how the process works. And if you actually try to study these tools, you realize that after the exploitation part, there's already post-exploitation. You'll realize how easy it is to exploit a computer just by knowing the type of server and the version, because it's out there in the internet. And then some of these are already open source. And that's really dangerous. You have to know these things if you want to protect your site. And if you think about it, there's Netcat also. Netcat is not really an attack tool. I think before it was just a normal utility. And then the difference between attackers and those that are system administrators, for example, include the fact that some tools which are supposed to be used for normal usage, they're actually used for different ways. They're used in different ways. For example, then Netcat can be used to do this and do that. And then, of course, Nmap is used for port scanning, but Metasploit is the attack framework, which is actually built in Ruby. Okay. So now let's look at the screen. So now, I actually started as a web developer about a couple of years now. But what I realized that if I wanted to protect the site, I should stop thinking of myself as a developer. I should think of myself as someone trying to make the site or make the business work. It made me realize that it's not about the role that you have in your company. It's about knowing what you need to know just to get things done. And in this scenario, this is actually some of the tools that network administrators use or system administrators use. So we have Netstat, and I realized that there's something called Unama, and it has been uploaded by the attacker, so that even if the server restarts, it connects back to the attacker machine. So that's the attacker machine. And here, since it's a test server, it's really weird that I think this is me, the one connected to port 22. But here, you have Unama, which is, even if you use PS-EF, Unama is like a way for the attacker to hide its presence, because there's something called uname inside Ubuntu. So this one was created in addition to uname, and you won't really see it unless you really know the servers in and out. And this is critical because if the attacker knows the system more than you, your site will get attacked and it will be really hard to recover. So knowing how to attack is critical. And it's important for us to understand that if we want to be able to stop attacks or even prevent most of the attacks, we have to know the possible ways that the attacker can actually attack your site, and then after the site gets compromised, it can be used to do other things. So the next step is about knowing what to protect. You'll get to see different ways in the internet on how to protect your site. But before trying to install firewalls, before trying to do this and do that, let's take a step back and try to understand what are we actually trying to protect. So last month, I actually presented this in the AWS meetup, and this is a simple system which I built to help us know which servers are actually on. So I actually created a simple Lambda function which just describes instances. And then I created a small internal mobile app using Objective-C. And then it connects to an API gateway. And then the API gateway triggers the Lambda function. So the advantage with this system is that it doesn't really cost us almost anything. You're probably paying for about 1 centavo for this system, but this system never goes down. So the advantage with having this system is that this system emails us every 12 hours which servers are open. Sometimes your developers will suddenly just spin up instances, and then at least with this one, this is already the first step in helping us detect which servers are actually running. And the logs can actually be found inside CloudWatch logs. So there's a centralized logging service in this system. And then there's the CloudWatch scheduled event, which is like a cron job, but this never goes down, and it's free also. So that's actually the goals in, for example, DillBrowser and the other projects that it has. It makes it easier for us to know which instances are running and which properties that we actually have. Because one of the things you have to protect is your money also, and the money of the company. Alright, so let's discuss the application-specific rules or nodes. So now, for those using Rails, and for those who have tried Sinatra or other smaller frameworks, or for example, Cuba, you'll realize that some of the features in Rails are actually missing in the smaller frameworks. That's normal, because Rails is a really big framework and it has a lot of helper tools inside. So tools. I call them tools. For example, sanitation, so on and so forth. Before trying to reinvent the wheel, you have to realize that there's a reason why Rails already provides that for you. There are already libraries which are made by other people, and a lot of other people have actually contributed to that project. If you try to reinvent the wheel, out of nowhere you'll realize that you're actually taking a lot of time trying to rebuild these things when other people have actually tried creating that for 1 to 2 years already. And that's a big factor. Well, for the databases, you have to know which features of the databases can actually be used against you. So sometimes when an attacker actually has access to your database and your attacker can actually drop the database out of nowhere, that's dangerous because the thing that you have to protect here is the data of your company. And then, finally, let's take a step back a bit more. It's not just the servers you're trying to protect. You're trying to protect your customers. You're trying to protect the brand. So even if the attackers actually don't have access to your servers, the attacker can actually do a lot of things which actually affect these things. And that's critical. For example, you have a denial of service attack. That will actually take up a lot of time and your customers will be affected as well. And that's critical. It doesn't mean that the attacker doesn't have access to your server, it's that your server or your business is safe. You have to take note that your customers can actually be attacked and their accounts can actually be compromised. So it's a really big field and you have to know that there's such a thing as such as social engineering. So even if you have protected your site in and out, your customers can be affected. The employees of your company can actually be attacked as well. So after some time, we actually have something like this. So we have DMZ and then we have private subnets. The advantage with having private subnets is that having private subnets prevent other computers outside this virtual private cloud container from actually accessing it. This means that only those inside the VPC, if configured correctly, can actually access your databases. And that's critical because most of the attacks are actually because there are open ports and so on and so forth. So the first thing that you need to take note of is first, try to remove your databases outside the server where your web servers are actually inside, and then try to protect the ports. Try to make the web servers the ones only able to access your databases. Alright. So remember what I said earlier, that security is like love. So the next lesson I learned is that it's important that you know how to recover. This is critical. Because even if you have protected your site, chances are that if attackers are really persistent, servers will actually go down. Sometimes, even customers will actually try to attack your site in different ways. So it's critical that we know how to recover. So it's like in love. So it's like in love where you only realize its importance until it's gone. So what we did is that since servers are actually, when the server actually went down, the test server went down, it actually took us about 2 to 3 days to prepare that server. Then since it got attacked, we can no longer use that server. So after that, we realized that, hey, maybe we can just automate the creation and the provisioning of the servers. So we use Chef. So this one is in Ruby also. And I had to create custom recipes to automate the creation of these things. So instead of us hiring a full-time, for example, architect and system administrator, what we did is we replaced that role with just a bunch of templates. And then, instead of us trying to build the server for about 3 days, the servers are actually up in just 15 minutes because everything is automated. So it's technically the same thing. Instead of having a human trying to create the servers manually, Chef actually helped us automate this types of things. The preparation and installation of the different, for example, Nginx, PostgreSQL, Unicorn, Rails, and Redis. And then, the last part when trying to recover is that you have to share. Sharing is critical because your developers, so that's the DG, the developers have to know what went wrong. They're not allowed to do the same thing over and over again. And awareness is critical because if the site went down last week and the site goes down almost every other week, then something's wrong with your system. Or maybe there's something wrong with the developers. Maybe the developers have no idea that having a chunk of code here will actually take down the site because it takes 20 seconds to load that part. So performance is actually critical when trying to serve a lot of traffic. Technical difficulties. Alright. So we're in the last part, automation. There's actually one of the major problems that companies have is that, are we really going to hire someone full-time to protect the sites? What happens if the site is already protected? We just make that person just keep on adding upgrades and so on and so forth. This is actually a resource problem. And one of the solutions that I proposed last year was that we automate a lot of these things. And the cool thing here is that even the configuration of the automation tool is actually automated and stored inside CloudFormation templates. So for those not familiar with all of these logos, let's just focus on the 3 logos on the right. So we have Central and we have Dealbrowser and BDML. What I realized is that these servers which are using Ruby, so Sinatra, Rails, Cuba, etc., the installation part there is actually very similar in this project. So probably 50 to 70% is the same. So what I did is I used Opsworks, which is a wrapper for Chef, to actually automate the preparation of the servers for those 3 projects. And for the virtual private cloud, which is the networking side, and Lambda functions, those parts are actually automated and documented inside the CloudFormation templates. So think of the CloudFormation templates as they're just files, they're just text files, and all the configuration stuff is stored inside those files. So for example, right now we actually have 4 to 8 environments. If I had to fix or configure one of the servers to upgrade it with some additional security stuff, all I need to do is update the CloudFormation template and then update all those 8 environments. This saves me time because instead of me manually updating each server, instead of me manually updating each virtual private cloud, the subnets, the firewalls, etc., it's all documented there. So even if I, for example, take a vacation leave, other people can actually know that, hey, this one is installed. They don't have to ask me because it's documented inside the template. And then finally, we have the setup where we have the web servers inside the public subnet. Actually, you can put in a private subnet and then just have a Dropbox. And then you have the databases, so you have a master slave setup here. And then the entire setup
is actually automated using CloudFormation and Opsworks. Alright. So that's pretty much it. So it's a really quick talk, but to sum it up, awareness is the key. In order to defend, you have to know how to attack. And before trying to protect your sites, try to know what you're trying to protect. Your keys, your secret keys, and so on and so forth. And then, try to know how to recover as well. Try to remember log. And then, finally, make the most out of your automation skills. So that's pretty much it. So, the end. So thank you very much and hope you got something from it.
Thank you, John. So the security hurt.
Yeah.
Any questions besides that? Well, you may, if there are none, you may approach Joshua.
Thank you.
Yeah, thank you.
Thanks, guys.